which is this chord right here, is going to be 240 units long. So let's just put a 240 somewhere. Let's use the smallest one. This is 240. We also know that ST is 240. We know that CU is 5x. And CV is 6x minus 7. Okay? Now, we want to find the radius of circle C. Now, I'm going to tell you guys now, you don't want to find the radius being CX or being CW. Okay? What you want to do is you want to draw another line to be your radius. And it needs to go from point C to an edge of the circle. You can pick any line that you want. But it has to be a good line that forms a right triangle. So what line from C to a point will form a right triangle? There's 4 possibilities. CT. Let's do that. CT, CR, CQ, or CS would work. I'm going to do CT in my example. You could have used any of the radiuses, okay? In my example, I'm just going to use CT. So first, I need to figure out, okay, CT is going to be a hypotenuse of this right triangle. So let me figure out what both of the legs are. Does anyone know what VT is? Ooh, I heard 120. You're absolutely right, but why is it 120?
Because it's bisected, so it's in half.
Okay, it's bisected. Noah, do you know why it's bisected? Okay, VT is half of ST. That is exactly right, but why? We need to know the why, remember?
It's being cut in half by
Because CV is a perpendicular bisected.
There we go. Since CV is perpendicular to that chord, it has to bisect it in half. Whenever you see this 90 degrees, right? And that's coming from the center of the circle, automatically assume, okay, it's a bisector. It's going to cut it in half. So this section right here is the same length as this section over here. SV is the same as VT, and they're both 120. Okay, so we found that leg. What do we have to do to find out what the 6x minus 7 is?
do the equation.
What equation?
6x minus 7 equals 5x.
Okay, very good. So we're going to set 6x minus 7 equal to 5x. But who knows why those two segments are equal? Why can... Because what is equal?
The chord.
Yes. Very good. So since those chords, since QR is the same as ST, their distances from the middle of the circle, from C, must be the same. So 5x can therefore be equal to 6x minus 7. Now let's say QR was 240 and ST was like 250. We couldn't say that 5x equals 6x minus 7, okay? It only works when the chords are the same distance, or the same length. Then they become the same distance from the center. Okay, so we got all that out of the way. So let's solve for x. How do we solve for x?
Add 7.
Let's add 7. 6x equals 5x plus 7. What do I do next? Minus 5x. X equals 7. Okay. What do I do with that 7? Plug it in. So we're going to get 6 times 7 minus 7, which is 42, minus 7, which is just 35. So we know that this length is 35. How do we figure out the final length of CT?
Plug it in, plug 7 in.
We did. We got 35.
Oh, we
Pythagorean
do
Mm-hmm.
120.
Very good, Teresa. We just have to apply the Pythagorean theorem now. Because we know two sides of a right triangle, so we can figure out the third. So CT squared equals 35 squared plus 120 squared. Question, why did I put 35 and 120 added together? Why is CT by itself?
Because CT is going to be our hypotenuse.
Very good. CT is our hypotenuse. So that squared must be on one side of the equation by itself. So we write this, and we find that CT squared equals, I think this is like 1,225. Can I get someone with a calculator to help me out? And then I think this is like 14,400. Yeah? And then CT squared should be like 15,600. I don't know.
15,625.
Okay. And then when we take the square root, what do we get? I think it's like 125. Okay. So our radius is going to be 125, which is B. All right, this is all about inscribed angles and polygons, okay? An inscribed angle and an intercepted arc, okay? An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. An arc that lies between two lines or rays or segments is the intercepted arc, okay? So take a look at the picture down below. The inscribed angle starts from the edge of the circle. So I want you guys to put a little dot at that vertex and put an arrow and put that the vertex is at edge of circle. Okay? This is different than what we've seen before. In the past, we've seen that vertex being at the center of the circle. Do you remember? With the central angles. This is what we call an inscribed angle. So the angle actually starts from the from the edge of the circle, okay? And then it's formed by two chords. So draw another two sets of arrows and label those two your chords, okay? And I spelled chords wrong. The measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. In other words, if we have a figure looking like this, where we have A, B, and C, the measure of the arc, AC, is going to be 1/2 the measure of the angle. I'm sorry, 1/2 the measure of that arc will be the angle ABC, okay? And I'll explain why this is. What I want you guys to do on your diagram is draw a center as best you can, and then draw the segments out to the same points A and C. This would be considered a central angle, so it would be the same as the measure of the arc, AC, right? But as we move this vertex further away, the angle becomes smaller. So the angle becomes smaller, but the arc length stays the same. Do you guys see that? The measure of the arc is consistent, but when we move the vertex further away from the middle, the angle becomes smaller. So I want you to highlight then this angle and this angle, and notice the difference. See how our two endpoints are the same, A and C, right? But your vertex is different. And by changing the vertex, moving the vertex further away, you make the angle smaller. So that's why it's equal to 1/2 the arc length, the measure of the arc, AC. Or you can look at it as the arc is 2 times the measure of the angle. just add a little hypothetical. Let's say that AC, the measure of that, is 100 degrees. If that's 100, the central angle is also going to be 100 degrees. But how much would the angle ABC be?
200?
Opposite.
50?
Just 50, okay? This is just going to be 50 degrees, okay? So just remember, your angle, the inscribed angle, is just going to be 1/2 whatever the measure of the arc is. Cool? All right. Now, this one's pretty symmetrical, right? B seems like it's symmetrical, but guys, it won't always be symmetrical, okay? So let's take a look at the next example. Inscribed angles of a circle theorem. If two inscribed angles of a circle intersect the same arc, then the angles are congruent. So angle 1 and angle 2 both intersect AB as an arc, okay? So angle 1 is going to be the same length as, or the same measure as angle 2. Lateral. So mainly what I want you guys to remember is that inscribed means inside, and it's inside a circumscribed circle. I want you guys to put skip up at the top, okay? We are not going to be covering the inscribed right triangle theorem, nor are we going to be covering the inscribed quadrilateral theorem. So put skip above both of those, and just jump to the useful fact number 1. And this useful fact is that an angle inscribed in a semicircle is a right angle. Always, 100% of the time, no matter what, okay? So as long as this line goes through the middle of the circle, right, it will create an arc of 180 degrees, right? So any angle that you put with its two intercepts here and here, in other words, that form a diameter, will be 90 degrees no matter what. Because it's going to be 1/2 180. Example 1, find the values of x and y in circle O. Okay, so let's take a look at A. This angle is 20 degrees. So if that angle is 20, so x is going to be 40 degrees. Let's take a look at y. Now look, y goes from here to here, and then from here all the way to here. So when we're looking at y, we have to look at the arc that's this whole thing. What's the measure of that arc? Of the red arc?
180.
It's not 180, it's 150. Very good. It's going to be 40 plus 110, right? So it's going to be 40 plus 110 equals 150. And then y is just going to be 1/2 of that angle. 1/2 that arc. So y is going to be 75 degrees. So guys, a really important part that you really got to understand is wherever the angle, like the two intercepts of that angle are super important because that will form your arc, and then your angle is just going to be 1/2 whatever the arc is. Or the opposite way around. The arc that's formed by that inscribed angle will be 2 times whatever the angle was. Okay, we're going to move over to B. Now, when we're looking for x, x goes from here to this point. So here's one endpoint. And then from here to the other, the other endpoint. So what we're looking for is the measure of this arc right here. And x will just be 1/2 of whatever that is.
I know.
What is it?
90?
Nope.
Oh no, 45.
Nope.
Sorry, it's a semicircle.
Let's see if we can use this to our advantage. If we know that that angle is 20 degrees, does that help us at all?
Yeah, it would be 40.
Yes, so this has to be 40 degrees, okay? This arc needs to be 2 times whatever this angle is. And then x has to be the same, right? So x has to be 20 degrees. Okay, now y is a little bit different. Y goes to here. Yeah. Why is x the same? Because look, aren't both those angles have the same endpoints, this one and this one? Yeah. So they relate to the same arc, right? So they're both just going to be 1/2 whatever that arc length is. So if you have any circle, right? And here's an endpoint, here's an endpoint. You can draw any angle that you want. They're all going to be equal as long as these two are your endpoints. Okay? No matter how you draw them. So this will be congruent to this, which will be congruent to this. Because this arc, whatever it may be, I don't know, 100 degrees, these are all just going to be 50. It's all going to be 1/2. Does that help? Yeah. Okay. So, now y goes from there to there. So we're looking for the measure of this arc here. Does anyone know what the measure of that arc is? Why is it 180, Samantha? Yes, it's a semicircle. Do you see how this line goes through the middle of our circle? We've got 180 degrees, so y must be? $90. There we go. Okay. Y must be a right angle. Beautiful. So x should have been 20 and y must be 90. All right, guys, 2 more examples. Check it out. Check it out. Okay. We've got an arc here formed by the angle here. What's the measure of x going to be?
140.
120 degrees. Because it's just 60 times 2. All right, we've got an angle here. if this arc is 140, what should this angle be? What? Nope, it's not 140. Remember, it's an inscribed angle, not a central one. 70 degrees. How could we figure out why?
Because 140 divided by 2 equals 78.
No. Yeah, we figured out that angle. But now we've got to figure out why.
Oh, I thought that's what you meant.
No, you're fine. Now we have to figure out this last arc.
I know.
There's two ways to do it. Marcos?
Add 70 and 60, subtract from 180.
Yeah, very good. So 180, you're on the right track.
And then
180 minus 60 minus 70 will give us this angle right here. Do you guys agree?
yeah.
Because inside of a triangle, there's only 180 degrees to deal with. So this is going to be what?
50 degrees.
50 degrees.
So it's 100.
So y must be 100. What was another way you could have figured it out?
By adding 140 plus 120 and subtracting by 360.
Very good, Juliana. You could have just done 140 plus 120 and then taken that away from 360. And you would have gotten 100. Either way is perfectly fine. All right, last example. Let's take a look. Now, in this last example, there's some things that make this example really, really easy. What do you think a really important part of this example is, Marcos?
The semicircle.
Very good, this semicircle. So go ahead and highlight the diameter that goes straight down the middle, and it creates two parts of the circle that are semicircles. Okay, now, once we've done that, what's x? X is really easy to find. Yeah, it's just 40, okay? Because it's going to be 1/2 whatever the arc is, and here's its endpoints for x. So it's 1/2 times 80, which is 40 degrees. So x is 40. Now, question. How are we going to figure out what y is? This one. So we don't know this angle yet or this angle, right? Could we figure that out?
Yeah.
How do we know it, Marcos?
Since it's a semicircle, it's 180 degrees. And divide that by 2 is 90.
Very good. These both have to be 90 degrees, okay? Because it's a semicircle, this is going to be, the length of this arc, the whole thing, is 180 degrees. So this has to be 90 degrees. Same thing with the other side. So we've got two right triangles that have the same, one leg and one hypotenuse that are the same. That means these two triangles are exactly congruent. So if this angle down here was 40 on this side, it's also got to be 40 over here. So y has to be what?
Y is to be... Hold on. 50?
Yeah, it just has to be 50. And that also makes sense, right? Because if this side up here, or this arc up here was 80, this has to be 100 degrees. Do you agree? Because it makes up a semicircle. And half of 100 is 50. Just those two. A skip on the last example, put skip here. Okay, we're not doing that last example.